Welcome to Chemistry in the Air. If you're joining us, welcome aboard. Okay, we started yesterday, introduction to redox. We took some notes. Redox reactions involve electron transfer, and oil rig is the way I use to memorize. Leo goes gur is another way, but anyways, oxidation is loss of electrons, that's oil. Rig is reduction, is gaining electrons. Other thing to think about is that a reduction reaction means that there will be a reduction in charge. Okay? Then we use the terms oxidizing agent and reducing agent. They're kind of backwards because the oxidizing agent actually is reduced, but it causes the other thing. It's the agent that causes the other thing to oxidize. Vice versa with reducing. We went through, we visually watched this reaction and then talked about it, just to nail in the vocabulary a little bit. We then took a quick look at balancing with electrons kind of thing, as overview, where we're going with this. Right now, though, here's what I'd like you to do. Jot this down, and then we're going to go through this as a group together. Figure out what's oxidized. What is oxidized and what's reduced? What's the oxidizing agent then? What's the reducing? Well, here's how we're going to do it. I'll give you an introduction and then we'll get into formal rules about how we do this. Kind of going ahead to show you what we're doing. We have to know the charges. Some of these charges are easy, but Re, rhenium, I don't think you come across that too much. You don't know that off the top of your head. Oxygen, everybody hope knows, is true negative. The only time it's not true negative is in a peroxide or when it's okay. More about that later. Underneath here, I'm going to just put some charges down. I know that oxygen, negative 2. I know that oxygen, negative 2. I'm only writing the charge for one of them. Okay. And in this particular case, I'm going to put underneath the rhenium, there's no charge listed there, so it has no charge, 0. I'm going to put that here, Re. Okay. Then I have to figure out all the others. You notice on every one of those other chemicals, they add up to -1 charge. They're not neutral common. But here's what I'm thinking. I might pick this up right now, but we'll go through something more formal. Oxygen is -2 and I have 4 groups of those -2. That means oxygen contributes -8 overall to the chemical, right? -8, and it adds up to -1. Now, arithmetic-wise, what does the rhenium have to be to make -8 add to -1? 7. Let me just jot that down. The Re must be a positive. Now I look at the iodine in IO negative. And oxygen is -2. I know that. And it adds up to -1. What does the I have to be in this particular compound? Arithmetic-wise, right? -2 plus something gives me -1 is 1, right? I'm going to put that down. But then in this one, it's not the same. IO3 negative. That's up to -1, but I've got 3 groups of oxygen, so -6. -6 plus something gives me -1. Well, that's 5. Right? So this is my thinking stuff. But I'm explicitly listing them out just so you can kind of follow my thinking. Now, I have enough information now to answer this question. What is oxidized? What is reduced? I tend to think the reduction first. Why? Because if you have charges listed, if you have electrons, you use oil feel dirty. But if you have charges, you look for the one that reduces from left to right in charge. We actually call it oxidation. Charge. Well, 7 goes to 0. That's a reduction. So I'm going to list on that what's reduced. It's the RE in RE negative. Okay. Nothing happens to the oxygen. What's oxidized? Well, it must be the other chemical, the ion negative. But let's just take a look. If reduced means it reduces in charge, this must increase, and it does. I goes to +5. 1 goes to 5. That's an increase. So it's oxidized. I'm going to say the answer here, oxidized, is I in the negative. Now, oxidizing agent, reducing agent. Oxidizing agent is what was added to ion negative to make it oxidize? This one. So, all I'm going to do is write down the oxidizing agent as the chemical, ReO negative. Reducing agent, what was added to the ReO4 negative to make it reduce the ion? Essentially, whatever's oxidized is the reducing agent, whatever's reduced is what? The factor. There's a reason. Now, I introduced you to something here, and I'm saying instead of charging, oh, doodle. You're just giving me heck the same question. Science appreciation. Okay, anyways. Well, I'm going to flip and we're going to get something down here. L2. Oxidation numbers. There's some rules on a handout. You don't have to write that down, but write down oxidation numbers. Find the oxidation number. I'll pause this and we'll take a look at a few of these. Okay. Oh. Okay. Well, I'll show you the rules in a minute. All right. On the back of your periodic table handout tip, so flip it right over. You see these oxidation number rules? Good. Okay. Yes, part of the handout. So these are the rules on handout, and they'll always have them on the final exam on any exam. So find the oxidation. Now I kind of have labeled these one stuff because it's going with rule 1 and so on. Okay? And I kind of go through the rules somewhat in order. The first rule, the oxidation number of an atom in its pure form as an element is 0. So when I list just Fe, that's 100% iron. I just listed as 0 because there's no charge listed to the top right. And then the second one, oxygen. Well, oxygen as an element is O2. It is 0 charge, even though it's in a group of 2. So we're going to write that down here. Now, oxygen, be careful, you know what I mean? In context, you know which is a number. It looks just like O for oxygen. That's a 0. And I had to copy down 2 more. Oh. And this refers to the second rule. The oxidation number of a monatomic single atom ion is equal to the charge on that ion. So this is really simple. The oxide ion, 2 minus, the oxidation number is the charge, -2. Aluminum ion, cation there, 3+, that's the charge. That's the charge, that's the oxidation number. This seems simple. And really, for ionic compounds, it's proper to say that the oxidation number is the charge. When we get into molecules, this is the reason why we use a different word, oxidation number. Okay. Now, a couple more for you guys to try. Now, you don't have to write out number 3. Oxygen is usually -2 on a compound. And 6, the exception is -1 in peroxide, because it's written on the sheet. So we're going to use 3 and 6. But 6, the most common oxidation number for oxygen is -2. Peroxide is -1. And fluorine is +2. So don't rewrite the rule. I'm just bringing that to your attention. But we're using rules 3 and 6 together to do this. Okay? Give me a second to just write out 3, 6, and then AB. So I say 3 and 6 are the rules that pertain to MgO and H2O. MgO, oxygen is usually -2 in compound, unless it's a peroxide. I will tell you if something's a peroxide. I'll put in brackets out. Or else, in this case, I'll just tell you what's wrong. But this one is MgO, it's a metal with oxygen. So I go about it this way. I wrote down in green here, Mg, and go, what is the oxidation number of oxygen? Well, it's in a compound, it's -2 in compound. That you can just assume. That means what does the magnesium have to be? Add to 0. That's rule 3, by the way. The sum of oxidation numbers in a neutral compound is 0. So that's why I'm saying 3 and 6. Well, it has to be +2, right? Arithmetic. Okay, so there we are. Now, B is actually hydrogen peroxide. You know, the stuff you put on cuts or stuff like that, right? So it's a peroxide. So we're going to make the assumption right away that since it's peroxide, we're using -1 for the oxygen. If I do this arithmetic, I won't write it out. H2O2. So we have 2 oxygen, -1 each, right? That means altogether it is -2 contribute. That means you've got 2 H's. They have to add up to +2 to 0 up. What is 1 H then? Arithmetic-wise? 1. Yeah, +1. Now H is tricky. Sometimes it's negative. Rule 5. You can see there, rule 5. Most common number for oxygen or hydrogen is +1. But sometimes with metals, it's negative. I will zip through here. So basically, compounds, if there's no charge written up at the top, it's 0. So you make sure that everything adds to 0. Now, well, I'll get you to jot down both of these. Rule 4 we'll talk about, and Rule 5. You don't have to rewrite Rule 5 like I did, hydrogen usually plus. That's written on your sheet. Give you a second to do that. Okay. Now Rule 4 2 negative. I put 4 there because it refers to Rule 4. Rule 4 is the sum of oxidation numbers in a polyatomic ion, any atom ion, is equal to the charge. So that means everything has to add up to, in this case, 2 -0.4. So we also know that oxygen is technically -2. So I'm going to write this down right away. We always write it down for 1 atom. On the side, we do a little scratch here for CrO4. So if I have Cr, I have 1 Cr in this compound. I have 4 oxygen. We know that 1 oxygen is -2. So 4 oxygens, I'm just going to do my scratch right here, is -8. I know that it adds up to -2. That's the charge on chromium ion. So right away then I think, okay, what's the arithmetic? I can do this in my head. I'm trying to show my face. If you need to do scratch work on the margin, do it. So -8 plus something makes -2. It has to be 6, right? I put that. This is what I figured out. I'm going to put it here. 1 chromate must be a +6. By the way, Always write positive or negative when it comes to this writing out oxidation. I want to see the positives. I know what to write down 6. Super positive. But write it out. Chemistry. And 5 refers to that hydrogen. Usually +1 unless it's with a metal hydride. First one, HCl. Okay, it's not a metal. It's +1. And hey, this makes sense because my ion charge of HCl is negative. That's expect. And put down my +1. Negative. In a metal hydride, well, anything to the left of the staircase other than hydrogen is considered a metal. Sodium. That's a +1 if I look at it. This is good because it's a metal hydride. -1 for hydrogen. That's just using rule of thumb. You're going to have these rules at all times. You tend to go through the lesson in order, pick up the rules that pertain to chemistry. Now, we're going to do a whole whack of things, and this is where we've got non-metals. I'm going to show you a lot of examples with nitrogen. Nitrogen can be positive, negative, depending on the situation. And lastly, something PCS. So here we go. You guys a moment to jot these down and pause the video. Okay. So I've nitrogen in 4 of these examples because I want to show you how it has many different possible numbers. If you looked up nitrogen's charge on the ion sheet, it would say -3. But these aren't ionic compounds for the most part. Nope, they aren't. Okay. They're molecules. And one polyatomic ion. So we've got to see. It could be -3, it could be positive something or other. We'll see. So what we do is we make our oxygen assumption. That was rule 6. So oxygen is -2. Generally, when you do these things, you go with the negative first, and then you figure out what the positive is. Positive is the one that jumps around. So I'm thinking, and I'll just jot down some arithmetic. I know that I have 1 nitrogen, 2 oxygen, and 2 oxygens would add up. I know it adds up to 0. So what is the nitrogen has to be? +4. Only way it adds to 0. You're not sure? Okay. I'm going to just take a second here. So 1 nitrogen because of that point. 2 oxygens because of the point. Right? Well, if you have 1 oxygen is -2. So 2 groups of -2 is I know that there's no charge on it. But it has to add up to 0. ABC. So in my head, I can do this. And if you want to write it out in the margin, you do that. I'm writing out what I'm doing. So I'm going to put +4. Okay. That's what I thought. Once again, for B, oxygen, I'm going to assume -2. I'm going to go through the list in order. By the way, what is Rule 7? I said I'm using it here, and I didn't even talk about it. In combinations of non-metals, the oxidation number of the more electronegative atom is negative. The oxidation of the less electronegative element is positive. Now, I should talk for a second here, because electronegativity, we haven't talked explicitly about that in 30 yet. We will, but hang on. The electronegativity, though, the most electronegative element is fluorine. As you get closer to fluorine, so as you go left to right on the periodic table, this won't show up on the video, but look at this. Fluorine is the most electronegative. So oxygen is second most. It's right beside fluorine. When you compare nitrogen to oxygen, okay, if oxygen takes on the negative charge because it's closest to it. Nitrogen. You're going up and down as you increase upper row, so you get more electronegative. So if you're comparing sulfur to oxygen, oxygen's the higher one, so it's the negative. Sulfur will be positive. SO2. But back to the actual example. Okay. We're making an assumption about, I'll do my scratch work here. N2O4, so I got 2 N's, and I got 4 O's. 4 O's is going to be a negative 8. I know it adds to 0. I actually have that. So, what do the 2 N's have to add up to? Positive 8. I can do this in my head. If 2 N's are positive 8, 1 N divided positive 4 again. 2 from the formula. N2. I'm thinking I'm doing the arithmetic for the compound with 2 N's. Yeah, but if 2 N's add up, let's take this through the other way around. If 1 N is plus 4, as we figured out, 2 N's times plus 4 is plus 4. Okay, you'll have a transfer. ABC, NH3. Okay, when I run through this, the rules, the oxygen rule doesn't apply. But there's a hydrogen rule again. And it's number 5. The most common number for hydrogen is plus 1 unless it's with a metal. Nitrogen's not a metal. I'm going to use plus 1 for oxygen or hydrogen. So I'm going to do some arithmetic on the side. So I've got 1 group of nitrogen, 3 groups of hydrogen. So 3 groups of plus 1 adds up to 0. So the nitrogen in this case has to be negative. Yes. Awesome. How do your parents know? Oh, well, they should hear it more often. Okay. Now this one, I'll make the oxygen negative 2 assumption. Then, well, I'm going to write this down. I've got 1 group of N. Color system. 1 N, 3 O's. We're trying to figure out the N, but we know that the 3 O's will contribute negative 6 to this. It adds up to negative 1 because of the charge on the nitrate. You know it's going to be plus 5.
No, because it has a negative charge, so it has to have at least 1.
I'll give you the chemical, and if it has a little charge, like negative 1 or negative 2. This is arithmetic. You can do it. I believe you. You're welcome. So, 5 is the arithmetic. Now, this is why I use nitrogen. Don't get hung up on a particular element always having the same oxidation. It doesn't necessarily. It depends what it's combined with, and like how it's combined. Actually, A, B, and D are all with oxygen, and we've got a couple of different charges, oxidation. Now, PCl3. This is rule 7 again. There's no rule for Cl. There's no rule for P. We look which is closest to fluorine, which is the most electronegative. And as we go from left to right, Cl is definitely close. It's going to be the negative one. You look up its charge then on the ionic table. It's negative 1. look it up very quick. It is. So I'm not going to write out the arithmetic. This is three groups of negative. One has a phosphorus has to be plus. Okay. You're like a mini genius. So I've got some practice. Hand them out.